Okay, so color in wide format digital print. Before we start talking about color in terms of what happens with your RIP and how you how color information goes through your RIP when you're going to be printing, we need to first of all start looking at what is color. So we need to have a base understanding of color before we start looking into what happens within color. So why do we have color management for starters? When we're printing images, we're trying to get replication and control of our colors. So we want to be able to print things the way that they were meant to be printed, and we want to be able to replicate that multiple times and sometimes across different devices. So the whole business of printing or displaying images that look like realistic depictions of the things they portray depends on exploiting specific properties of the way humans see color. So color management is an extension of that. So what does this mean? Well, different devices produce different colors. So if we're talking about monitors or digital cameras, perhaps, or the human eye, each of these are going to see, interpret, or portray colors in a different way. The same happens with printers. So if we are using printers, each printer will print colors slightly differently. There are also a number of other elements that affect your colors as you're printing. So this could be from the RIP that you're using, so the engine that runs your printer, to the heat or the temperature in the room that you're printing onto, or the heater on your printer, humidity levels, the white balance of the material that you're printing onto. So all materials that you're printing onto could be white, but there's different levels of white as well, and colors will look different on slightly different levels of white on the background. The color space that you're printing from, so that the profiles and things that attach to your images, so these could be RGB or CMYK, spot colors, for example, these will all affect how colors look whilst you're printing. The light source that you're viewing your print under makes a big difference as well. And time, so how long it takes to print, the time of day that you're printing, these can affect your prints as well. Now, it's easy often when doing training to just tell people, here's what you should do in order to achieve certain colors, but color isn't quite that simple. And if we did that, then you wouldn't know what happens when things go wrong. So the idea is for us to in this webinar is to explain a bit more about the background of printing and color, so that you understand why things go wrong when things go wrong, or why things change when certain things do change. Because the aim of this is that we can all get happy prints, happy customers, happy happy staff, people knowing exactly what's happening whilst they're printing. If we talk about color management, we've got two bits on the screen here, two bits of text from Wikipedia and from the ICC. So we'll just pick out a couple of these elements. So in digital imaging systems, color management is the controlled conversion between the color representations of various devices. The primary goal of color management is to obtain a good match across different devices. So as different devices have different colors, portray colors in different ways, have different values, different inks, different light sources, all the rest of it, we want to be able to portray images on a screen similar to how we would print them on multiple devices, in essence. Then we've got something from the ICC at the bottom there. So the International Color Consortium profile format is to provide a cross-platform profile device format. This, or device profile format, this means that we want to create a system that works across multiple devices that people will be able to understand, and each of the different devices will be able to understand as well. We'll come back to the ICC a little bit further along through this presentation. If we start at the beginning, when we talk about what is color, it's all to do with light in a way, because we were talking about how humans see color. There's different parts to color. Obviously, if there's nothing to see a color, then there is no color. So color is a property of objects, green apples or brown shoes, for example. Color is a property of light. So if there is no light, then there is no color. And color is an event that happens in the observer. So our eyes and our brains see color. When we have all three of these, that's when we have what we would call color. So an event that occurs among three participants. So if we have a light source, and then we have an object, and then the light reflects off of that object and the human eye reads that light source, that's what we as humans understand as being color. The visible spectrum of color, or what we see as color as humans, is the spectrum in between ultraviolet and infrared radiation. In between there, the wavelengths are what the human eye can recognize as being different colors. And the colors go through a spectrum of red, orange, yellow, green, blue, and violet, and all of the colors and all of the fades in between. So that's what the human eyes see as color. There are different types of color, or different modes. When we're talking about color management, it's easier to talk about these as color modes rather than just color. So the three types or modes that are most commonly used in digital print are RGB, CMYK, and something called LAB. So first of all, we'll talk about RGB. RGB is what's called an additive color mode. This means that we start off with black, which means no color. And then when you have all of the colors, that creates white. So normally when we start talking about RGB, often this doesn't make sense to people because we're used to thinking of colors onto a background for coloring in, for example. So if you had some felt tip pens and you color onto a white background and you put all of the colors down, you wouldn't get white. But when we're talking about RGB, we're talking about light sources. So when you have no light, you have black. So if you turn off all of the lights, you have black. And if you turn on all of the lights, then you have white. So you add light sources of various wavelengths which combine to make different colors. If anybody's ever seen an RGB LED color module, they have red, green, and blue lights. And if you turn off all the lights, it goes black. If you turn on all of the lights in an RGB color module, it will go white. So all of the colors combined create white. So when we're talking about RGB, we're talking about using light. Just as a side note, RGB and CMYK are both trichromatic. Okay, this isn't super important to understand, but this basically means that we have three colors which combine to create all of the other colors. So the three-channel design of the human retina is also based on a trichromatic formation. 3 pigments on a paper, or 3 phosphors in a monitor, for example. The importance of trichromacy in the graphic art industry is that we can simulate almost any other color by using 3 well-chosen primary colors. 2 colors aren't enough, 4 is often too many. In the RGB color mode or color module, there are approximately 16.5 million colors that you can produce in theory using the RGB color mode. So this is an image that was taken into Photoshop, and we used the eyedropper tool to select one of the colors. And as you can see here, there's a red channel, a green channel, and a blue channel. And these channels go from 0 to 255 because they're not to do with percentages, they're to do with the wavelengths and the light sources. So 255 times 255 times 255 is how many colors you can produce in theory using the RGB color mode. It's over 16.5 million, but it's approximately 16.5 million colors. If you get your calculator out, you can figure it out, the real values there. All RGB colors are device specific. So colors that are device specific means that they are viewed on or portrayed, or they read colors using a device, and those devices will have specific capabilities. So if we talk about a monitor, for example, different monitors will be able to read color or portray color, in different ways, depending on the quality of the monitor, how old it is, the technology that it uses to show the colors. Same goes for a scanner. A scanner is actually an input device that will shine a light onto an object and read the reflection and that creates an RGB file. Similar to a digital camera, again, this reads all of the light that comes into a camera and creates a file, an RGB file from that. And the human eye works in the same way. Most RGB devices are actually input devices rather than output devices. But the most common one that people would think about when they think about RGB is a monitor, which is an output device. Obviously, a monitor shines lights so that it shows color, and then the human eye would read those colors. So all RGB colors are device specific. Next up, if we look at CMYK, CMYK is a subtractive color mode. So in essence, it's kind of the opposite of RGB. So in the CMYK color mode, we start off with no color, which means white. And then if we combine all of the colors, we reach black. So this does make sense normally when we're thinking about how most people think about color, because we start off with a white bit of paper, for example, we color some of it in, and then we see that color. But the CMYK model works by partially or entirely masking colors on a lighter, usually white, background. The ink reduces the light that would otherwise be reflected. So it's called subtractive because we subtract the brightness from the white. So white means that all of the wavelengths are being reflected into your eye, and then black means that all of them are absorbed, in theory. You can't get a perfect black in print because there will always be some reflection. Some of you may have seen something called Vanta black that they created, which does absorb all light, but that's not something that we use in print. In the CMYK color mode or color module, there are approximately 1 million colors. Again, similar to in the RGB color mode, when we zoom in here, we can see that when we've color picked one of the colors from this image, the CMYK channels go from 0 to 100 because they're using percentages of formulations of ink in this example. So the colors go from 0 to 100, and if we times 100 by 100 by 100, we get 1 million. That we don't times it by another 100 for the black channel, because the black doesn't actually add any extra colors to the formulation. The cyan, the magenta, and the yellow are what create the colors. The black ink is just there so that if, for example, we wanted to just print a solid black, we don't have to put down 300% ink of the 100% cyan, magenta, and yellow. We can just put 100% black. So it's a key color, and hence the K for black. It's also there for helping to create darker colors as well. But it's an additional channel, but it doesn't actually add any color. And again, with CMYK, all CMYK colors are device specific, meaning that a device will create the colors that we're talking about. In this case, we're talking about digital printers, and each digital printer will create colors slightly differently. Even if you have exactly the same device with the same configuration, obviously there are manufacturing tolerances and things, temperature changes, all the rest of it. So there will be some small changes in how they portray colors. The final color mode that we're talking about is LAB. So if we see this sphere on the right hand side, this is a visual showing the LAB color mode. So in the LAB color mode, we've got 3 channels or 3 axes. So we've got the lightness to darkness channel, which is the L channel. The A channel, we've got the red to green opposition. And in the B channel, we've got the blue to yellow opposition. Within this sphere of color that you can see, in theory, we have every single color theoretically possible. So within that sphere in a digital space, we have all of the colors that are available. Unlike the RGB and CMYK color models, the LAB color is designed to approximate human vision. So it was created to help us as humans to understand color in different ways, and especially in terms of color management when it comes to converting colors, as we'll talk about later. The LAB color space includes all perceivable colors, which means that its gamut exceeds those of RGB and CMYK. So LAB is the largest of the color spaces. If we had RGB and CMYK, they would fit within this color space. The CIE models allow us to represent numerically the color that people with normal color vision actually see. So there are other modes as well as LAB, but LAB is the main one that we would be using within the CIE color modes. But it's based around how humans see color. So some of these points might be a bit far-fetched, as this one. So the LAB model is device independent. This means that the colors are defined independent of their nature of creation or the device that they are displayed upon. So with RGB and CMYK, there is always a device that is reading, showing, creating these colors. With LAB, think of this more as the mathematics of color. So it's a theoretical color space. It's not shown or created by anything. So it's a digital color space. And the final point, as I said, a bit far-fetched, many of the colors within the lab color space fall outside of the gamut of human vision and therefore are purely imaginary to humans. So these colors cannot be reproduced in the physical world. So as I said, this is more like the theory of color. And because the human eye is based on sort of an RGB color mode, we're not going to be able to see all of these colors. Another point that's just kind of a side note here, it might be interesting to some of you color geeks out there, that if you look at that color space, if I just zoom in a little bit here, we can see that you could have a yellowy red, for example, because they're next to each other in this space. But we couldn't have a yellowy blue because they are at opposite ends of this sort of spectrum. Same, you couldn't have a greeny red, but you could have a greeny blue. Okay, so that's a bit about RGB, CMYK, and LAB. And just to break down again, why are we managing color? Because different devices produce different colors, and we're trying to recreate colors across different devices. And we want to be able to control that color. We also have a number of different sources for our color, especially when it comes to digital print. It could be a photograph from a digital camera. It could be a design created in a digital design program such as Illustrator or Corel, SignLab, anything like that. It could be that you're getting these files from your customer and you don't understand, you don't know the nature of how this was created or the original color spaces. We also have RGB and CMYK values, and we also have spot colors, and we have vector and bitmap information. And all of this is created in a single file that your printer needs to print accurately. So we need to have color management to manage these processes. So why do we manage color? If we're talking about RGB and CMYK conversions, as we mentioned earlier, the RGB color space has a lot more colors capable within it than the CMYK color space. So if we're going from an RGB design file or an RGB color space into CMYK, then we have the issue that we've got a much bigger color space going into a much smaller color space. This isn't always the case. Often we are using CMYK based profiles or data, but we are going from one format or one color space into another. So one device's native space into another. So we still need to manage those conversions. But if we talk here a little bit about RGB going into CMYK, it helps with the visualization when we talk about 16.5 million colors going into 1 million colors. So if we are doing this, how do we still preserve the quality or the similarity to the original file? We do this using ICC profiles to map or translate the colors from one source to another. And we use rules on how we map and translate these colors. These rules are called rendering intents or matching methods. You may have heard of these sayings when looking at color previously. So if we take a step back and talk about the ICC, the International Color Consortium, it was formed in 1993 by 8 industry vendors in order to create an open, vendor-neutral color management system, which would function transparently across all operating systems and software packages. So these guys all got together because before this, everybody was creating, understanding, or converting color in a range of different ways. And they wanted to standardize how color management was done so that everybody's on the same page. everybody can create and understand color in the same way. So this is just some information from the ICC. We don't need to read it all. As I said, you'll be able to watch back this presentation and read any extra bits as we come to them. But the most important bit is down the bottom here, where it says an ICC profile is one that conforms to the ICC specification. By conforming to these specifications, profiles may be exchanged and correctly interpreted by other users. The two main types of profiles that we have are source or input and destination or output profiles. And these essentially consist of tables of data that relate the device coordinates to those of the standard color space defined by the ICC. Some of this language, when you're talking about color, does get quite technical. So we'll break this down in the next coming slides. So profiles, as we said, we've got input and we've got output profiles. So your color management system does two things. It assigns a color meaning to RGB and or CMYK colors, and then it changes those colors as they go from one device to another device so that the output colors remain consistent. So first of all, if we talk about input profiles, an input profile describes the colors within a file or a device and how they should be reproduced. Some of the common input profiles are, for example, Adobe RGB 1998 and sRGB. All images should have an input profile attached to the image. That profile may be embedded in the document. It could be applied by a user, or it could be supplied by a default setting in your design software, or you can override this in Roland VersaWorks, for example. So if we take the image that's on your screen at the moment, this was a photograph that I took on a digital camera on my phone at a football event. So when I had that digital file format, I then took that onto my computer and I went into the properties or the details from this image. You might not be able to see this. If I just zoom in a little bit, we can see here that it says that the color representation for this file is sRGB. That means that when my digital camera took this picture, it used the sRGB color space and it attached that information to the digital file when it was created. So that means that the next device in this process can look at that information. An embedded profile doesn't change the color values of an image. It just tells your color management system what the color values represent. So it's basically saying that this image was created in this color space. So this is how this image should be reproduced. So it's the first part in a chain, and then the next parts in that chain can see that information and can understand it, edit it, record it accordingly. So I hope everybody's still following with me. Any questions so far? I haven't seen any pop up into the questions box, but if hopefully you're still following and still understanding everything that we're talking about. Okay, so the next part, output profiles. So an output profile describes to a device, your printer, the colors that it should be producing. A printer output profile is based on the colors that are achievable by a specific combination. And that's the printer, the media that you're using, the ink formulation that you're using, and the RIP that you're using. So all four of those elements need to be configured in order to create an output profile. An output profile can be chosen manually or by the media profile that you select when you're in Roland VersaWorks. So when you choose a media type in the quality settings tab of VersaWorks, the job settings, so within the job settings of VersaWorks, the profile you choose, for example, generic vinyl 1 or a media specific one, will have an ICC output profile built into that profile. And this can be seen within the Media Explorer. So if you're in VersaWorks and you go to the Media tab at the top of VersaWorks, for example, and you go to the Media Explorer, this will list all of your profiles that you have for your device, as in this screenshot here. And down in the bottom corner there, just highlighted in blue, it says Printer Profile. So that's the printer profile that's been embedded into this media profile. That's an output profile. And then you've got different color management options within VersaWorks as well. So we'll come to those in a moment. So as we mentioned earlier, if we're going from RGB to CMYK, we have the possibility of roughly 16.5 million colors, and then we have the possibility of roughly 1 million colors. We also have different file formats. So we have photographs with embedded information into them. We have things that are created in your design package. We have vector, we have bitmap. We have all of this different information from different sources within one design file. And then this needs to be printed on your printer. This is why we have color management. When we're going from RGB to CMYK, for example, if you did a straight conversion without any color management, you would get inaccurate results. It's hard to represent this in an image on the screen. Hopefully you guys can see in this image here, this was just a conversion going from an RGB image straight to a CMYK image without any color management, without any conversions. And the RGB to CMYK means that you lose information, you lose depth of image, you lose data in darker areas, you lose the nice balance between the image. So RGB to CMYK needs a non-device specific translator, and this is where lab color comes in. So RGB, all of the colors are mapped into the lab color space, and then from lab, they're translated accurately into CMYK. This is what I was mentioning earlier when we said we had tables of data, meaning once you've got tables of data, we can start to go from color between color spaces using specific translations. So how do we manage these conversions? Well, luckily, VersaWorks does it all for you. So you don't have to do any of these conversions yourself, but this is a big part of what a RIP does when it's looking at color. So when you choose your media type, this has a profile built into it. And then we also have color management options as to how it's going to translate and interpret this data. If, for example, we are talking about RGB, as I said, this isn't just for RGB, it's for any device that's going or color formats that's going from one device to another. But if we had a photograph taken and that had an input RGB profile, that would be ripped into lab. And then from lab, it would be translated into CMYK using the media profile. The media profile is important as that has ink limits and it reads the white balance of your material and it knows how to print accurately onto that material. And then we can accurately reproduce the color data. So when we're trying to reproduce a good visual representation for colors that are out of range, range gamut is the amount of colors that a device can reproduce, rendering intents come into play. So as we mentioned, rendering intents or matching methods, these are the rules that they use for translating data from one format into another format. I've seen a question come in there on the chat. It looks like quite a long one. I'll wait until the end to come back to that if that's okay there. We'll answer that at the end just in case we answer it in the next steps as well. So when we're looking at rendering intents or matching methods, when the gamut of the source color space is bigger than that of the destination, so the file format or the information that's attached to your image, if that's bigger than your printer's color space, then often saturated colors are liable to become clipped or inaccurately represented. The color management module can deal with this problem in a number of ways, and the ICC uses what are called rendering intents. There are a number of rendering intents. The main ones are perceptual, often called photographic as well, relative colorimetric, there's also something called absolute colorimetric, and saturation. So if we look at this little gamut picture up in the top right here, we can see that the RGB color gamut is bigger than Pantone, for example, and much bigger than CMYK. And the gamut, the circle around the outside there would be the lab color space. So we'll break down these different rendering intents for you. So perceptual, this is also sometimes called compression, means that the gamut of the file is compressed to fit within the CMYK output profile, and the colors that were in gamut are moved to suit. So I've created these visuals here. If we imagine that that red shape that you can see on your screen is your printer profile. So that's the amount of colors. This is the gamut of your printer. So anything within that color space, your printer can print. And all of these tiny dots that we've put into this file, this image here, represent the different colors from an image or from a file. So you can see that some of those colors fall outside of the printer profile gamut. So they need to be inside the printer profile gamut in order to be printable. So using this method, perceptual, what happens is all of these colors are compressed or moved inwards to fit within this color space. The ones that are outside are moved in, and the ones that were already inside our color space are moved inwards as well to suit the rest of the movement. So it means that perceptually, all of those colors keep their relationships, so the distances from each other, but it's all just compressed to fit within this new color space. So at the end of it, we have all of the colors producible, but they have all been shifted together to fit within this new color space. So this is one method, and it's called perceptual because all of the relationships between all the colors are still maintained. So perceptually, the file looks the same. All of the gamut's just been squashed to fit within this new color space. Next, we'll look at relative colorimetric. So out of gamut colors are mapped in. So again, if we look at this diagram, same as the previous option, all of these colors that are out of gamut are moved in gamut. But in this option, all the ones that were previously were inside gamut, in gamut colors, are preserved in their same location. So those aren't moved as well. This means that more of the colors that were already in that gamut are accurate. So they stay where they are, and then we just bring in the ones that were outside. So we have more accuracy from the original colors, but the relationships are not as photographic as they were in the previous option. And finally, we have saturation. This means that the out of gamut colors are mapped to the edge of the new gamut, and the in gamut colors are moved towards the edge as well to create the most saturated versions of those colors. Hopefully that all made sense. What I've got here is I've just linked to a little video that I found which shows this in a visual as well. So we'll see if this works. Just let this load. So this would be colorimetric, where the out of gamut ones are moved in gamut, but the in gamut ones stay where they are. This one is perceptual, where they're all moved inside, but the relationships change. And then saturation, where they're all pushed towards the final outside gamuts of their of the new color space. So that's a quick little video showing you the images that I mentioned before. And this is from a bit of software that shows what a profile looks like when it's built. So if you see those axes on the bottom, those are the LAB axes, and that space that you see in the middle there is a printer's color profile. And what's going to happen is all of the colors from an image are going to be mapped into this color space. So if you can see all of these tiny little dots and little squares that are around this color space, they're from an image. So this shows you that a lot of those colors from that image are outside our color space, and they need to be moved inside that color space so that we can print them. This is what happens within rendering intents and matching methods. So which rendering intent do we use? Again, it depends on the user. It depends on the person that's going to be printing the job and the client, so whoever, what their use is of the output, I guess. So if we talk about perceptual tries to preserve the overall color appearance by changing all of the colors so that they fit within the new color space, whilst preserving the color relationships. It's a good choice for images that contain significant out of gamut colors. If you've got lots of colors outside, then it's better to move all of them and move the inside ones a little bit. It's also a really good choice for where you've got where you need to have accurate color blends and color fades. Relative colorimetric takes account the fact that our eyes adapt to the white of the substrate we're viewing. It maps the white from the source white, so from the file, into the destination, so that the white on the output is the white of the media rather than the white of the source space. If that makes sense. It then reproduces all of the in-gamut colors exactly, as we mentioned, and it just brings in the out-of-gamut colors to their closest reproducible hue. It's often a better choice for images rather than perceptual, as it preserves more of the original colors. However, I'm sure if you spoke to sort of some photographers, they might argue between these 2 points, depending on what their vision is for this image, because it might be that they want more of the original image colors to be maintained, or it's all about the relationship between the colors. This is where you, as somebody who's looking at color management, needs to understand these processes in order to be able to make a good judgment call when it comes to printing people's images. Then we have saturation, which tries to just produce vivid colors without worrying about the accuracy so much. So it converts saturated colors in the source to saturated colors in the destination, and it uses bright and vivid colors, signage, etc., but less useful for accurate color replication. Something to be aware of within relative colorimetric, is if we have all of those inside colors and then we map in the outside colors, but we don't move the colors that were in Gamut already, what can happen is where you had a color that was further away and a color that was in Gamut, with perceptual, they move together as they come in Gamut. With relative colorimetric, the outside one may move and it may come too close to another color that was existing inside in Gamut. This can lead to what's called posterization. It's not something you would often see, but it's just something to be aware of. This image is obviously a highly posterized image, but it means that rather than having a smooth blend, the colors might go too close to each other and the human eye might not see the difference as much, so you get steps in color, or you can get steps in color. So what does all this mean when it comes to printing? So color management in VersaWorks. First of all, spot colors are not affected by color management. Something important to note. Earlier this week, I did a video called 5 in 5 using spot colors. Go and check that out on our social media channels or on YouTube if you want to know more about spot colors. But spot colors have their own sets of values which are forced through the system. So when you choose your different color management presets, if you have spot colors in your artwork, they will not be affected by the color management options that you choose, as long as in the file format tab of VersaWorks, you have the convert spot colors option selected, and those spot color libraries are built into VersaWorks. As I said, for more information on that, you can check out our 5 in 5 video that I did earlier this week. Only RGB and CMYK process colors will be affected. It's found under the quality tab in VersaWorks. And sorry, this presentation, I haven't updated that. It says there are 10 preset options. There's actually, I think, 12 now, because we have a couple of new color management options which were introduced for VersaWorks 6. All of these color management options can be set as default in the queue properties. So you can have it so that each of your queues has a default setting for the color management, or you can always change it per individual job as well. The industry standard ones that we have as our color management presets are the pre-press options, and these are based around printing conditions in those regions. So strange as it is, light, how people want to view color, social issues mean that in different regions there are different recommendations for color. So I'm in Europe, so pre-press Europe would be the recommended industry standard that we would use. We also have some Roland presets which we've introduced. So true rich color, max impact, sign and display, max density settings, and density control only, which have been introduced as we see these as suitable options for color management as well. So color management presets. Oh, let's just take a step back there. When you select one of your color management options and you click on the properties box in VersaWorks, this window will pop up. And this window explains what happens within that color management preset. So here, as an example, we've taken true rich color as the preset. and it's given us some information about what's happening. So first of all, if we go to the bottom of the window where it says use embedded ICC profile, this means that during the color conversions that VersaWorks is making, if there is an ICC input profile attached to the file that you're printing, do we want to use that profile in our color conversions? So as it says here, use the image embedded profile. So if the image, we know where it's come from, or we've created the image and we know that the color information attached to that image is accurate, then we normally would want to use the embedded ICC profile, because that's telling our color management how to create that image or how to convert that image. The reason we might not want to use the embedded image is if it's been converted, or if somebody's attached a new profile to an image and we don't know if that's accurate. For example, if somebody sent me a design file, I could open that in my design package and I could reassign different color information to that file, which means that from its original, it's changed. So therefore, I might not want to use the embedded ICC profile. I might want to override that. Some images will not have an embedded ICC profile as well. So if there is no embedded ICC profile, as it says here, we then switch to a simulation target profile. So these are the profiles that can be attached for RGB information and for CMYK information within a file. A file can have both, okay? If we're bringing in PDFs or EPSs, these can hold a lot of information, and they can hold raster, vector, RGB, and CMYK information. So if we don't use the embedded profile, or there isn't one, then we switch to the RGB and CMYK simulation target profiles. We also have the matching methods, which is the sort of squashing mode that we went through earlier. And that can be chosen. You can choose a different matching method for raster data, so pixel data, bitmap data. And you can choose a different one for vector data as well. And then finally, there's an option there. Does the color management preset use preserve primary colors? So say, for example, I had a sign that I was printing and it had a 100% yellow background, but it had a photograph within that sign. What could happen is, as the color management tweaks the information that's within that photograph, it may also tweak the other information. So it might mean that my 100% yellow doesn't print as 100% yellow. So you have an option here to preserve any 100% color values as 100% values as well. So all of these color presets in VersaWorks all use the same rendering intent for both raster and vector data, except the max density settings and the density control only setting. The density control only setting means that no color management is done. So the file is printed as it is. It can be useful for some vectors. Okay, let's just break that apart for a second. So density control only, as it says in the name, means that the printer will just use the density control settings from the profile. So the profile says how much ink the printer needs to put down for that material, and it will keep that information, but it doesn't tweak any of the color information that goes through. So if I have built a vector CMYK based design using specific CMYK values, it will just push those CMYK values through. There won't be any changes made. And a star note at the bottom there, if the rendering intents do not match for raster and vector, then we can get an issue between raster and vector color matching. So again, let's just explain that a little bit. If, say, for example, I had a photograph of somebody wearing a blue t-shirt, and then in my design package, I used my eyedropper tool and I selected that blue color for the t-shirt, and then I created some text, the Roland logo, next to that person using the same blue. The logo would be vector, the t-shirt would be bitmap, and if the rendering intent was different and the color was out of Gamut, when it brings it in, it might not look the same. So I may have an issue between my raster and vector color matching. If this does happen, there's something called a full page conversion mode, which allows for this, and we'll change them accordingly. You can also create a custom setting within your color management. So This is one that I may often use myself, but as I said, it's very much up to you as a printer to understand what's happening with your color management. So if I did choose a custom preset, Adobe RGB 1998 is probably the larger of the RGB simulation target profiles, so that might be the one that I would choose. CMYK, I would probably either choose myself the Roland wide gamut CMYK profile, which is a new one that was introduced for the True Rich Color preset, or probably pre-press Europe, because that's the European recommended. The matching methods, personally, I think if I'm printing photographs and raster information, I would rather use perceptual than colorimetric. If I'm using vector, I would probably use colorimetric to maintain as much color information accurately as possible. I probably would preserve the primary colors, because if I have 100% values, I think it would be right to keep those. And I would use the embedded ICC profile. However, these settings can change depending on your output, what the specific file is. Okay, creating a color management test. So all of this stuff that I've been talking about so far has very much been theoretical. You know, what happens in the RIP, what happens with these different color spaces and all the rest of it. It can be useful to see some of this information in a visual format as well. So what I would recommend is that you create yourself a color management test if you want to test what happens with your different presets, or if you've got a really complex file. So if you've got a complicated image that's come from a customer, and you want to test the best way of printing it, you could also do this color management test. So what did we do? What I did here was created a design file, and I placed some images that had color information attached to them. So these 3 photographs at the top. Now in Illustrator, which was the design package that I used here, when I placed those into the image, I did not embed them. I placed them so that they maintain the color information from the original file. This means that if you embed them, they take on the color management options from your design package. So I placed these into the image so that they maintain the color information that was attached to those images. And I chose images based around red, green, and blue-ish with skin tones, because skin tones are quite important when we're looking at photographs. I also created some vector swatches at the bottom there for RGB, CMYK, and some color blends as well, so that I could see what would happen to those. What I then did was brought that file into VersaWorks, and I went down to the Marks tab in VersaWorks and selected Print Job Properties. That means that underneath each of my prints, it will print the data of how that image was printed. I then took that image and I right-clicked on it in VersaWorks and went to duplicate job, and I duplicated it 11 times, meaning that I had 11 copies of the same file within VersaWorks. Not 11 copies as in 11 repeats of one job in my job settings, I hope this makes sense, but 11 actual different files of the same job. And I nested those jobs together within VersaWorks. Here now, as you can see, we've got 1 copy of each, but it's 11 different files nested together. The benefit of doing that is that if it was 11 copies within VersaWorks, then it would have 1 color management profile for all of them. However, if I've got 11 different files within a nest, I can select these images one by one, and under the quality setting, change the color management preset for each one. So this gives me the ability, if I have 12, to choose all of the different color management presets. And because under the file format tab, we have print the property information, underneath each one, it will say which color management preset was used when we print them. And we print those out so that they're printed at the same time, using the same printer onto the same material. Then we have a visual that we can look at afterwards, and we can see what happens to the different bits of information within that design file using different color management presets. I hope that made sense for everybody. There we go. That's my overview of color management for you guys. A lot of information that I found has been useful has come from this book called Color Management Real World by Bruce Fraser, Chris Murphy, and Fred Bunting. It's fairly old now, but it's still a lot of useful information in there. It is quite high it's not the most easy reading, I think I'd say. But when you're talking about color management, you do get into a lot of theory and a lot of technical aspects. And there's also a color management qualification that I took, which you can do online. Can't remember exactly what it was called. I probably should have put it in this presentation. I think it was Color Management Fundamentals by the IDEA Alliance. That's IDEA Alliance in one word, IDEA Alliance. That was what it was. So again, if any of you are interested in scrubbing up on your color management skills and getting a qualification, you could look at that as well. So that is it for my overview on color management. What I will do is now jump to the questions. So if anybody has any questions from any of that information that I shared, please ping them into the questions box now, and I'll see if I can answer those for you, unless we have already answered them in that presentation. So first question, let me just read this for 2 seconds, then we'll talk about it. Okay, so the first question, I read that when printing the Roland Color Systems library chart in VersaWorks 6, you should change the color management setting to density control only. However, the colors look quite different when you select different color management settings when printing to final media. Is this advice wrong? And should I be printing the color management charts with the color management profiles I normally use for jobs? Printer is the BN20. Okay. So this was a question from Dan. The color management charts that are built into VersaWorks, when we use those and you print them, they will ignore the color management settings that you use because they are spot colors. So let me just see if I can quickly just see if I can open VersaWorks a minute. I don't have it open. And I might be able to show you quickly. But when you print your color management charts, because they are spot colors and they're built into VersaWorks, they don't use the color management options. So they should look the same regardless of what color management option you choose. They will use the profile information. So depending on what profile you use, media profile, they will look slightly different. So yes, if you're printing the color management, the color charts, the Roland Color Systems libraries from VersaWorks, be sure to change the media profile in your Q setting before you import the color chart. And then that will use the correct ink levels and things from your media profile. So let me just see if I can yep, you guys should be able to see my VersaWorks now up on your screen. So if I just show you on this VG 62640 here, if I go to edit QA settings, let's wait for this to open. What we would need to do is go to the quality tab and choose the media profile that we want to print with. Select the media profile and the quality settings, the print quality settings. The color management will not make a difference. Click on OK and then go to media, color chart type 1, for example, and import this into QA. It only ever comes into QA, so you have to use QA as your settings. Just wait for this to import, 2 seconds. Now I can show you. I think my computer's running at full speed here trying to do the live webinar, and I've got a few other programs open as well. So it's just importing the color chart there for a second. Okay, so it's just about done. It's just processing. Oh, it looks like I've got one up here as well. You can use this one, sorry. So let's just use the one at the top maybe. Bear with me, I think my computer's struggling a little bit. Got the blue spinny wheel of death. But as I said, the color charts are built-in spot colors, so they will bypass the color management settings that you use. Looks like my VersaWorks is having issues whilst I've got a million programs open and I'm streaming live. Bear with me a moment. Right, well, just whilst that's processing, I'll just jump onto a couple of other questions. Could we have a copy of the test file that I created? You can, but it's a pretty large file that I created because the images that I embedded, didn't embed, I linked, are rather large images. So I wouldn't be able to send it unless I sent it via WeTransfer or something like that. It's better for you to make it yourself, is my honest answer, because you can choose images that are more relative to your industry or your types of printing. And what I did in Illustrator was I placed those images into Illustrator. I used Illustrator, you could use a different bit of software. And I linked to the file location on my drive so that the color information was taken from the file on my drive and put into Illustrator and taken with the file when I saved it. Quite an important note there is if you're saving as a PDF from Illustrator, don't choose the default PDF settings because that does not take the input color profile information from placed images. Whereas if you choose the high quality print setting, it will. So just as a quick note there. I'd say make it yourself. I've got your guys' contact information, so I'll have a look after this and see if I can arrange for it to be sent. But it would be easier, or it'd be a better process for you to create it yourself. So if I just jump back into VersaWorks a second, so I've got my color chart here, and if I open the color chart, just to show you quickly what I meant by the spot colors being built in and not needing to use your color management settings. Just a moment. Again, computer's struggling a little bit. Here we go. So if I go down to the file format tab, see here it says spot colors, and it's got a list of all of the spot colors here from the color chart because these are built into VersaWorks. And the option to convert spot colors is selected as a default, and you can't deselect it because it's a color chart that's built in. So they've disabled the function to be able to change this color chart. The whole idea is that there's only one way of printing this. You can choose the media profile, but the different color management settings will not change how you print this chart because it's built in. Hope that made sense. Any other questions? Sorry, another question from Dan. Even if I use spot colors, I definitely get different color results between color management profiles. So what am I missing? Just selecting that box, the convert spot colors option. That's the main thing for if you're printing spot colors. First of all, the spot colors have to be built into VersaWorks. So if we go to the edit tab in VersaWorks and go to spot color settings, these libraries here on the left-hand side are all of the spot color libraries that are built into VersaWorks, meaning that the conversions are all built in for it to be able to see the spot color and create an accurate representation of it using its CMYK profile. So first of all, the spot color has to be within these libraries, and you have to have that option, convert spot colors, selected when you print those spot colors. Otherwise, they'll be treated as CMYK profile images or process colors, sorry, and the color management will change them. So there's another video that I did all about spot colors. It'd be worth checking that out as well. They're on our YouTube channel as well, I think. Another question that's come in, which one is better, file for RGB format or CMYK format for VersaWorks? Okay, one is not better than the other. They're just different. So the whole point of color management is to try and understand sometimes one is better, sometimes the other is better. Also, color is very subjective. I might say that I prefer my file format to be in one format when I print it. Somebody else might say they prefer it to be in another format because they prefer the results that come out. So when we're talking about printing with color, it's about talking to the customer, the person who's going to be having this print, so that they can understand, or you can understand from them, what is it that they're trying to achieve. And if we understand color management as a whole, we should be able to choose the format that works best for those customers. So in essence, another answer might be, if the file format originally was RGB, so it was a photograph, for example, it has the choice of a bigger gamut. And then what we want to do is use color management, because it's a really strong tool, to convert that RGB when we're printing it. So it's better for it to stay in RGB and for color management to do the conversions, rather than us flattening it to CMYK to then print it. I think when people are talking about print, if they've been in print for a while, if they've come from other print backgrounds, they often want everything to be in CMYK because they're used to sort of printing in CMYK plates and things. But we're talking about digital, it's slightly different. And so if you're designing a file in a vector format on yourself, then maybe designing it in CMYK is better because it's just going to be printed in CMYK. So create it in CMYK so there's not as many conversions that need to happen, or you might not create it in a bigger color space, which then has to be converted so you can get more accurate colors. However, if that file was going to be utilized elsewhere, so say I was creating a design that was going to be used on my printer because I was going to print it onto the side of a van, for example, but it was also going to be used on a website and on TV advert, then I might design it in RGB because when it goes onto the website or the TV advert, it has more colors that it can use. And then I just convert those to CMYK when I'm printing it for my van. No straight answer, I'm afraid. Because I said color management is a big thing to understand, and there's no straight answers. I can't just tell you do this. Yeah, it's all about understanding what happens in the background so that you can create the best choices yourself. I hope that answers your question to some degree. Any other questions that are coming in? A couple of people said they need to sign off because they've got other bits and bobs to do, but and a couple asking for the test file. But any other questions? We'll see if I can answer those for you. I hope you guys have found this useful. As I said, color management is quite a big area, and often people either choose to ignore it or they don't fully understand what's happening. So hopefully this has opened up some of the answered some of the questions for you when we are talking about color, because it has to be complex. Hopefully going through that presentation has helped you to understand that. You know, there's a lot that happens within color. People often say one of the most common questions is, why don't the colors on my screen look the same as what I print? Hopefully you'd be able to answer that now. You know, the colors on your screen are using different color modes. They are using lights to show color. They use a very different format from what a printer does. You can't print using lights, so you have to do the best that you can. Another easy way of answering that question would be to say to somebody, have you ever seen with your eyes somebody wearing a fluorescent high-vis jacket, for example? Yes, you have. If you don't have a fluorescent ink, then you won't be able to print. It won't look the same as the fluorescent jacket does to your eye, because you know it's a real life thing as opposed to a printing thing. You know, so if you look at something with your eye that's very bright, you can't print that because it's coming from a larger color space. That normally helps people to understand the differences when they're dealing with this. So excuse me. So again, thanks for joining. Hope you guys found it useful. Any further questions, you can always get in touch with us. This webinar will be available, as I said, down the line. Check out our YouTube channel on Roland DG UK. Check out our website, rolanddg.co.uk, and go to the training section. There's all of the past webinars there in the webinars on demand. You can always connect with us on social media channels as well, Facebook, Twitter, Instagram, and myself and my colleague Ollie from the Roland Academy in the UK, we both have Facebook accounts, so you can always get in touch with us and ask questions and see things on there as well. Follow the Roland DG UK page on Facebook, lots of them being delivered there as well at the moment. And as I said, any questions, get in touch with us. You can email us, academy@rolanddg.co.uk. That's it. I think I've been talking for long enough, so I'll leave you guys to it. But hope you guys found this useful, and we'll see you guys soon. Hope you're all staying safe out there. Cheers.